Let's come to fusion. Fusion reaction occurs when two or more atoms fuse together to form bigger atom, or when two or more smaller nucleus fuse together to form bigger nucleus. In this process, what happens? Mass of this side is higher than mass of this side. Some mass is lost. That mass gets converted into energy, and this is a common reaction which happens in our nuclear, which happens in our sun. Okay. Fusion takes place at very high temperature. जैसे in sun, the fusion reaction takes place at 15 million degree Celsius. अब देखो, what were the how did we divide sun? We had core, radiative zone, convection zone. Fusion was not taking place in radiative zone. Fusion was not taking place in convection zone. Even in corona, where temperature is in millions of degrees Celsius, corona में we have temperature of millions of degrees Celsius, तभी वहां से solar flare निकल पा रहा है, सब निकल पा रहा है. Even there, what is happening? Fusion is not happening. Fusion is only happening in core, where temperature is more than 15 million degrees Celsius. Temperature is more than 15. Yesterday, when we were studying black holes और वो सारी चीजें, हमने बोला everything eventually fuses into iron. फिर iron does not further fuse to make something else, right? No matter how large the mass is. Iron फिर was getting converted into neutron star. Neutron star will eventually become black hole, or depending on how large the size is and so on. है ना? तो why is it so? Why fusion only takes place till iron? Not beyond that. Why iron is not fusing to form other things and produce energy? वो सारी चीजें आज पढ़ते हैं. But coming back to fusion takes place at very high temperature. First of all, why? Because of this reason, fusion reactions are also known as thermonuclear reactions. Fusion takes place at very high temperature. Very high temperature, thermonuclear reaction तो है, पर कौन सा? Thermonuclear reaction. Nuclear reaction है, but thermonuclear reaction. Why? Because it's taking place at very high temperature. Now, why would fusion take place at very high temperature? Why would fusion take place at very high temperature? इसको भी समझते हैं. देखो, this is the nucleus. Hydrogen का nucleus है. What does it have? Proton. Hydrogen का nucleus, what does it have? Proton, proton, proton. Or for that matter, any nucleus. They have proton and neutron. Proton is positively charged, neutron is neutral. तो net nucleus का वो क्या है? Charge क्या है? Positive. Positive and positive things repel each other. Now you want them to fuse. Will they repel each other? If they repel each other, what will have to do? You'll have to provide them very high speed. You want them to fuse, but when they move towards each other, they are repelled. You'll need to provide them very high speed so that they are able to counter this repulsion, Coulombic repulsion, electric repulsion. दोनों positive, they will repel each other. So they should be given very high speed, and that high speed will come at very high temperature. And that is why fusion के लिए in fission that is not what we have to do. हमें fission में positive चीजों को जोड़ना नहीं है. We have to make them go away. So fission can happen at normal temperature, but fusion के लिए you'll need very high temperature, and that is why fusion reactions are also known as thermonuclear reaction. बात समझ में आ रही है? Why fusion reactions will be called thermonuclear reaction? Okay. Now, so for fusion occurs at 15 million degrees Celsius. What is the need of extreme high temperature to overcome the electric repulsive force? ये बात समझ में आ गई? But still, fusion are important as a source of energy. देखो, nuclear fusion is important. Why? Because raw material is easily available. Hydrogen, पूरे universe में सबसे ज्यादा क्या है? कौन सा गैस? Hydrogen. It's very efficient also. Hydrogen converting into helium can produce way more energy per nucleon than uranium breaking into barium and krypton. Similarly, अच्छा सबको डिस्टर्ब करना पड़ेगा क्या? नहीं, फिर ऐसे ही चलने दो. डिस्टर्ब नहीं करना है किसी. Now, safety. Fusion energy reactions are inherently safer when compared to uranium reactions and all. अब uranium reaction में क्या होता है ना? यूरेनियम रिएक्शन में वो चेन रिएक्शन बन के न्यूक्लियर बॉम्ब बन सकता है, बट दैट्स नॉट द केस विद फ्यूजन। एनवायरमेंट फ्रेंडली है, यूरेनियम का जो रिएक्शन होता है इट प्रोड्यूस अ लॉट ऑफ रेडियोएक्टिव वेस्ट व्हेन कंपेयर्ड टू हाइड्रोजन फ्यूजिंग टू फॉर्म हीलियम, एंड देन it can also ensure long term energy security for us. Why can it ensure long term energy security? Because for uranium we are dependent on other countries. For uranium we are dependent on other countries. Hydrogen तो बहुत है ना, H2O can be converted into hydrogen. H2O को आप इलेक्ट्रोलिसिस करोगे, it can break into water, can break into hydrogen and oxygen. राइट, ये भी जिनको नहीं पता वो हम पढ़ेंगे। तो हाइड्रोजन इज अवेलेबल बहुत सारी क्वांटिटी में, बट इन स्पाइट ऑफ ऑल द एडवांटेजेस टिल डेट we don't have any commercially working fusion reactor in the world. In spite of all the advantages, hydrogen is very efficient in producing energy, hydrogen can fuse together to form helium, hydrogen is the most common gas and everything, we don't have a fusion reactor in the world. Because fusion करवाने के लिए जो conditions चाहिए, that they are very difficult to achieve. Very high temperature, 15 million degree Celsius plus temperature चाहिए fusion के लिए. Achieving that is difficult. More importantly, when you achieve 15 million degree Celsius का temperature, what happens is everything expands. As temperature rise, atoms will move away from each other. Fusion के लिए you would want what? Sufficient plasma particle density. Plasma means hydrogen ion का sufficient density should be there. If the density is very less, if they have moved away, things would be problematic. Ab in sun, what is happening? Gravity is keeping them together. Very high temperature, they're moving very fast, but gravity is keeping them together. So score में it's possible. In this room, it will not be possible. 15 million degree Celsius. Please understand, iron melts at around 1500 degree Celsius. 1500 degree Celsius पे iron melt हो जाएगा. Now we are going to 15 million degree Celsius. So achieving 15 million degree Celsius, पहला problem. At that temperature, ensuring sufficient plasma density, second issue, and then sufficient confinement time. Now, what is the sufficient confinement time? देखो, when we try to achieve this in lab, we at very small scale we achieve temperature of 15-20 million degree Celsius. At that time, things start exploding. So there should be sufficient confinement time before everything explodes and all. We can see fusion occurring. So these three conditions are required for fusion to occur, and achieving these three conditions are very difficult. Now, एक और चीज ध्यान से नोट करना, इस पे प्री में क्वेश्चन आ सकता है. दिस अ वेरी इंपॉर्टेंट एस्पेक्ट. देखो, वी हैव various isotopes of hydrogen, H, D, T. Do we understand the meaning of isotopes? We have various isotopes of hydrogen. Now, these various isotopes of hydrogen, like hydrogen can fuse to form helium. But it has been shown by scientists that most efficient fusion reaction in the laboratory setting will be the reaction of two hydrogen isotopes, deuterium and tritium. सबसे efficient क्या होता है? Deuterium and tritium. We are not going behind in the science behind it, but इसे याद रखो, in laboratory setting, which are the atoms which we are easily able to fuse, when easily मतलब easily नहीं, 15 million degree Celsius and all, but we are it is easy to achieve, or we are finding it more comfortable to fuse. What is that? Deuterium and they are both hydrogen के isotopes. Okay. Now, so far we understand fusion. Fusion is smaller nucleus fusing to form larger nucleus and producing energy. We understand that. Everyone is comfortable. This is what is happening in sun. We understand that. Now, on Earth, achieving this is difficult because temperature required is 15 million degree Celsius or more. We need sufficient plasma density and sufficient confinement time. Achieving this has been difficult. So scientists all over the world have been working on achieving this. And there are two broad ways by which they are trying to achieve it. One is by inertial confinement method, other is by magnetic confinement method. And then there is a hybrid method also. यहाँ पे some other variants also exist, such as those which use combination of these two methods, that is known as magnetized target fusion. So we have inertial confinement method, we have magnetic confinement method. Don't worry, आपको ना ये थोड़ा technical लग रहा होगा, नहीं है. Once you are done with the class, you will understand each and every word which is given here. You will go out today at 9 कि यार क्लास में जब घुसे थे तो our understanding of a lot of things were lesser. Now when we are going out, we are very clear about nuclear science and technology, plus we are able to solve all the PYQs, plus we are ready for anything else that UPSC gives. हम इतना पढ़ लेंगे न्यूक्लियर साइंस टेक कि भाई या तो हम क्वेश्चन करके आएंगे या कोई नहीं करके आएगा. That is the confidence. I do not say I'll make you attempt all the questions. नहीं, I cannot. I do not know what UPSC is going to ask. कुछ भी पूछ सकते हैं ना वो. But you will be best prepared people. तो अभी you may be feeling कि यार all these terms are complicated. No, we'll explain each and every of these terms. But सबसे पहले fusion में in two different ways we are trying to achieve fusion. One is inertial confinement method, other is magnetic confinement method. Inertial confinement method is being tried at National Ignition Facility of US. NIF जो हम बोल रहे हैं ना, एक लैब है यूएस में. इट इज बीइंग ट्राइड एट नेशनल इग्निशन फैसिलिटी इन यूएस एंड दे हैव फॉर द फर्स्ट टाइम अचीव्ड समथिंग इंटरेस्टिंग. In December 2022, they were able to achieve break-even or net positive energy gain, and in July 2023, they were able to do this at bigger level. The gain was almost of 2 times. Now, what is meant by this? It means this. ये let's say this is in lab. This is where we are making fusion occur. Fusion यहाँ पे करवाना चाह रहे हैं हम. यहाँ पे we'll have deuterium, tritium, and we want to fuse them. So to fuse them, we'll have to make temperature go to 15 million degrees Celsius. For that, we'll have to provide them energy. Let's say laser से हम इसे energy दे रहे हैं, so that temperature goes to 15 million degrees Celsius. Then they will fuse, and when they fuse, what happens? Energy will be produced. For the first time, break even was achieved in 2022. Break even मतलब the energy that you are taking in, you are able to produce more energy by that. Break even क्या होता है? Profitable. A business becomes profitable. आप जितना पैसा खर्च कर रहे हो उससे थोड़ा ज्यादा कमा रहे हो. आप जितना एनर्जी कंज्यूम कर रहे हो, you are able to produce slightly more than that. So far, we had not even achieved break even. In July 2022, the National Ignition Facility of US was able to achieve break even. I'm telling you, 10 years down the line, 15 years down the line, when we are actually able to develop fusion reactor. अभी हम पूरा develop नहीं कर पाए. When human beings are actually able to develop fusion reactor, I promise you, जब भी वो होगा, देखना, for this experiment, National Ignition Facility and their scientists are going to get Nobel Prize. This is such a huge achievement. Abhi, as we complete this section, you will understand the significance of it. They're definitely going to get that. Because generally Nobel Prize is given for those things which has huge impact on humankind. mRNA vaccine को Nobel Prize मिला because during COVID-19 it had huge impact on humankind. जिसने insulin पहले discover किया और develop किया, they got Nobel Prize very quickly because insulin was something that was needed by so many people. It had impact on so many people. Okay, so coming back to what did they achieve? Break even. पहले कब? In July 2022 and in December 2022, and then in July 2022 they were able to achieve a gain of almost 2. That is, for every 1 unit of energy which was being supplied to the compartment, they were able to produce 2 unit of energy. They were able to produce 2 unit of energy. So what did NIF achieve? Break even first in December 2022 and July 2023. What were they able to achieve? Break even तो था ही, but gain of 2. What is meant by that? Did we understand it? हमारे सिस्टम को जितना एनर्जी सप्लाई हो रहा था, it was able to produce more energy than that. अच्छा, by the way, do you know hydrogen bombs have been made? न्यूक्लियर बॉम्ब टेस्ट हुआ था, उसके कुछ सालों बाद हाइड्रोजन बॉम्ब बन गया था. मेकिंग हाइड्रोजन बॉम्ब इज इजी. डू यू नो व्हाई? बिकॉज यू फर्स्ट यूज अ यूरेनियम बॉम्ब, बहुत सारा एनर्जी प्रोड्यूस हो जाता है, टेम्परेचर गोज टू मिलियंस ऑफ डिग्री सेल्सियस. इन दैट हाइड्रोजन कैन फ्यूज एंड प्रोड्यूस बॉम्ब एंड प्रोड्यूस अ लॉट ऑफ एनर्जी. You will say, then why can't we do that in nuclear energy power plant? Because in nuclear energy power plant we do not want a nuclear blast, we want controlled reaction. In nuclear energy power plant, what do we want? We want controlled reaction. There we cannot allow temperature is going to millions of degrees Celsius. इस पूरी building में millions of degrees Celsius temperature जाएगा, everything will melt क्या? Will not exist. Even shadow will not be there. right? So we want controlled energy production in fusion, and that has remained a challenge.